Hello, welcome to Physics Explained, where physics problems meets with step-by-step solution. Let's dive into today's problem. So here is the problem. Consider two identical homogeneous balls A and B, the same initial temperatures. One of them, the B, is at rest on horizontal plane, while the second one means the A hangs on a thread. The same quantities of heat have been supplied to both balls. Are the final temperatures of the balls the same or not? So here there can be four cases. Either A and B have same final temperatures, or A's final temperature can be greater than B's final temperature, or B's final temperature can be greater than A's final temperature, or maybe we cannot predict from this given assumptions or criteria according to the question. So let's try to solve. Uh, so, so here let's first try the case of A. Case A. So let's first remember something. I will remind you. If there's a body, maybe a 2D body or a 3D body, if I give some heat to it, so there can be three things. Either there will be temperature change, or there will be expansion, expansion, or contraction, or there can be state change, like ice to water, water to vapors. So I think as you don't know how much heat you gave, we here don't consider the state change property. We are here considering the temperature change or the expansion. So let us try on A. This is the A body. If we give some heat Q, so there can be two processes. It will change its temperature, also it will expand. So if it expands, that's like this. So here you see this is A, but I will say this is A dash, the new size I refer to. Initially, A is, I will say, the center of mass, the point I will assume. The center of mass of A at initial position is this. But after expansion, the new center of the body is positioned lower than the initial position. That means initially A is at higher potential energy, but after expansion, A came to lower potential energy state. That means there is a potential difference change. So, how can you say that? So, let's Q is the heat given to A. Uh, some part changed its temperature and some part decreased its potential energy. So, I can say Q equal to QA. Let's the part of Q which change the temperature minus which decrease the potential energy. So here I can say Q as for temperature change we use mc delta T. For expansion we know for here we are considering linear expansion of center mass. So I can say that LF equal to Li 1 plus alpha delta T. Sorry, uh, I can 1 plus alpha delta T, where alpha is the linear thermal coefficient. Linear thermal coefficient. Uh, so here I can say that let I change in temperature be delta T A. So Q A will be mc delta T A minus change. Let its radius be R. So what will be change in its position of center of mass? So that will be so the length will be mg. The change in length will be R alpha delta T A. So here we can write that delta T A change in temperature of A is basically Q by mc minus mg r alpha. Now let's find for case B. Similar, here is B is rested on a horizontal surface. We gave it Q temperature, Q heat. So B expanded. We are not considering any change in state. So initial position of center mass of B is here. Final after expansion center mass position is here. So initially B is at a lower potential energy state. After expansion it becomes to higher potential energy state. So there is also a potential energy change. But here it is increased. So suppose we give it Q, this QB represents the part of heat which is used to change the temperature of B plus some work is done as it is increased. So I can say delta plus delta P. Think I can more A part clearly say that I can here see that initially it is high potential energy in case A, then it turned to low potential energy. So we are here considering no loss of energy. So that where does the change in potential energy go out? So it added up to the heat given, but here in case B, it is if we QB which changes the temperature, it is Q which we gave minus delta P because that Q has done some work and then it changes the temperature. So here we can say Q equal to QB MC delta TB plus here again mgr the same dimensions in the same component alpha delta tb. You can say delta tb is basically q divided by mc plus mgr alpha. Here you can see that the denominator part in this case is less. So delta ta is greater than delta tb. You can say T final of A minus T initial is greater than T final of B minus T initial, as the both have same initial temperature. Cut T final of A is greater than T final of B. So the final temperature of A is greater than the final temperature of B. I hope you understood well. See you on next video. If you have some problem want it to be solved, drop down in the comment section.